We've been given a network A to E, and the first thing we're being asked to do here is to use Kruskal's algorithm to find the minimum spanning tree for the network. Write down the order in which you add edges to your minimum spanning tree. So they're looking for us to have also sort of written down how we're doing this, but that would make sense for Kruskal's anyway. So Kruskal's says do your list. It's got the L in it, so I remember that as a list of vertices. Before we do that, let's just change our x to an 8, so we know we've got that in as well. Now, whenever I'm doing a minimum spanning tree, I always draw what I refer to as the skeleton. So this is just A, B, C, D, and E. Now this just stops me creating any cycles as I go through. So the first edge that I'm going to do, because remember I'm listing it here, so it's going to be B to D of weight 8. So BD weight, sorry, not weight 8 at all, weight 5. Okay. So that's that one sorted. I'm now going to use AE, which is 6. So we will join those two up. And you can see I'm just creating the minimum spanning tree, which answers part 2 anyway. So it's worth doing, even if you're quite confident. So I've got those two sorted. It's now going to be EB, which is 7. So E to B, which is 7. I suppose convention would say I'd write that one BE, just the first letter first, but it doesn't really matter. And then finally, I'm going to add BC for length 8. Now, I could have also, with Kruskal's, have written down that I was going to put in between these two. I could write in D to E of length 8 and cross it out. That would be equally correct, okay, because both of those are using the algorithm. So when you've got a repeated or an edge which is the same, it doesn't matter the order that you choose. So you could have chosen BC first and ignored DE entirely, or you could have had DE but seen that it created a cycle, so you didn't want to use it and therefore it's crossed out. With this, I've then also answered part 2. So this is all part A, but effectively it's all together. So this is part 1. This is the order that I've added them in. This is part 2. And then finally part 3 is asking for the total length of the spanning tree. So I've got 8, 7, 6 plus 5. 8 and 7 is 15, 20, 26 is my total length. Okay, so hopefully reasonably straightforward Kruskal's question there once you've put x is equal to 8. So we're being asked to explain in part B why x cannot be equal to 7. So Alice has drawn the same network but changes the value of x. She correctly uses Kruskal's algorithm and the edge CD is included in her minimum spanning tree. So by including the edge CD, that has to mean that she's correctly applied the algorithm. So she's correctly applied the algorithm from B to D to choose the 5. She's correctly applied the algorithm to choose the next smallest, which is A to E for 6. And she's correctly applied the algorithm to say that BD is 7. Now, if x was 7, the next edge she would have to choose would be this one here to C for 7. Okay, but it says that CD is included in her minimum spanning tree. So as a result, this cannot be the one she chose, and it has to be there. So why can x not be 7? Well, x cannot be 7 because otherwise, so let's write this out, x cannot be 7 because then CB would be in the minimum spanning tree and not CD. So for part B part 2 then, we're being asked to write an inequality for x. So we know that CD is going to be part of the minimum spanning tree, which gives us a good understanding of what X is going to be. We've kind of shown what it's going to be in B anyway. But let's just take our time. So if she's doing Pascal's algorithm on this, she's going to go B to D for 5. She's going to go A to E for 6. And she's going to go E to B for 7. Okay, and then from there, we're saying that she's going to include CD and not BC. So as a result of that, part 2 for B, CD is going to have to be bigger, X is going to have to be bigger than CD. It can be equal to CD, whatever that length is, because in Pascal's, if you've got two equal, you've got a choice, so she could have chosen to put CD in. But we do know what CD is, so let's remove that. So X is going to have to be greater than or equal to the length 10. So for example, if X was equal to 11 there, Pascal's would say choose CD, not BC.